and welcome to a new episode of the STEM Brothers podcast. I'm Quasi Vincent.
And I'm Basir Vincent.
And we are the STEM Brothers. Well, thank you for coming back and listening to another episode. This is episode 6. Basir, we got 6 of these down. Can you believe it?
Yeah, 6, and we'll hopefully keep coming strong.
Yeah, absolutely. So I want to get right into the purpose of today's episode, or the subject matter that we will be covering in this episode and subsequent episodes after this. And that is the topic of how interconnected our world is becoming. And by interconnected, I mean the prevalence of devices, equipment, everything around us being connected to the internet or being able to be controlled remotely somehow, some way.
Absolutely. It's amazing how these devices are becoming more regular in our everyday life. So, Quasi, I saw the coolest thing at your house. You want to tell the audience, when I had to go to your house and stop by, how I got in?
Well, what you were able to do is actually punch in a code that we pre-programmed for you remotely in order to enter the house. So the locks on the home are now, we don't have a mechanical key and lock setup anymore. Let me correct that. We have that as a backup, but the primary method is an electronic control pad that has a special code, and we can lock and unlock the door remotely using a smartphone application. We can log into a system, and we can, number one, tell if the door is locked or unlocked, and then we can lock it or unlock it accordingly, and we can also set a passcode for entry. So in the case that you're talking about, we were able to simply set you up with a code so that you can enter the home. And we also were able to monitor the alarms of the home, so we knew when you had entered the home because we got an alert, and a whole bunch of other kind of cool stuff that, again, all of it is due to different devices, locks, alarms being connected to a network in our house, and then that network subsequently being connected to the internet. And
that is the coolest, and that's what we're going to talk about today. The common term for that is the Internet of Things. And the Internet of Things is the network of physical objects, or quote-unquote things, embedded with electronics, software sensors, and network connectivity, which enables these objects to collect and exchange data. We're seeing this more and more now with smart fridges and smart locks and smart lights and smart everything. Almost every device in your house will eventually be interconnected.
Absolutely. So that's one example in my home, and then you gave some great examples that are occurring in homes all across this world. So we felt that it was important to talk about this rising shift in technology, this rising trend in technology, this Internet of Things. We thought it was important to cover it, talk about what it is and some of the opportunities from a career standpoint, and also just being able to inform folks about what's going on, so that when you're out there making decisions about the homes that you buy, or the pieces of, or appliances that you may buy, different things like that, just understand that a lot of things now will have a component to them where they'll be able to communicate with the internet. or be integrated into a home network so that you can monitor it, control it, etc.
And why is understanding this important to the future, and why it's important to understand the science, technology, engineering, and math that's related to these devices is it could be a potential career. Now, for example, Kwesi, in your situation, if someone were to break into the network that you had or something were to go wrong, that wouldn't be good for you, right?
Absolutely. It'd be terrible. You know?
It'd be horrible.
Yeah.
Now, imagine you're Penn State University or some other business. But in this case, we're going to talk about Penn State University. Today, we get a chance to interview one of my close friends, Larry Murray, who is a network engineer, and he works for Penn State University. And during our discussion, we'll talk about the idea of a network, which is one component in what we were talking about earlier, which is the Internet of Things. So if you remember, the Internet of Things is a network of physical objects. So someone needs to be able to specialize in how that network works. What's the security behind that network? What happens if a piece of that network can't communicate with another piece of that network? There's a person who learns about these items and helps a business or a university deal with setting up this network.
Absolutely. So we want to let you guys listen to our conversation with Larry. It was a very informative discussion. And on the other side of that conversation, we'll come back and sort of summarize some of the key takeaways from that discussion. So without further ado, when we come back, we will be on the line with Mr. Larry Murray. All right, welcome back. And we have on the line, as promised, our guest for this week. Basir, please introduce this.
It's my pleasure to introduce one of my closest friends, Larry Murray. He is a network engineer who currently works for Penn State. Welcome, Larry. How are you doing today?
I'm doing good, man. Thanks for asking.
All right. On this podcast, we try to reach out to people, let them know the various type of jobs that someone in the STEM field can go. And you are a network engineer. So to start off by just telling us a little bit of what you do.
Okay, so I do network engineering, like you said. My main goal is to monitor the BAS network on campus, and BAS stands for Building Automation Systems. This network is responsible for heating and sending programs that do heating and cooling and monitoring electricity, the levels of steam, and energy usage on campus. The other network that I'm responsible for monitoring is the security network. So that network monitors card access and the cameras, so that if anyone's thinking of stealing something ever on campus, know that I'm the guy that's responsible for making sure you get caught. And then the other function of that network is for the emergency phones on campus, which they've been expanding quite a bit this last year. So that's monitoring that and making sure it's working is probably 70 to 80% of my job, and the last 20 to 30% is troubleshooting and deploying smaller networks into new buildings that as they go up. And right now we have a pretty big project where we're, I guess the proper term would be retrofitting and changing out the old network equipment and putting in new, more efficient equipment currently. But yeah, that pretty much sums up my job.
That's cool. A little bit of setup, a little bit of troubleshoot, and some remodeling. So especially at a big school like Penn State, I know there could be a whole bunch of things that can go wrong. But really, what happens if you're not doing your job right? What can go wrong, and what are the steps that you take to fix that?
Well, there are multiple things that could go wrong. I'm going to name the things that are definitely involved with me first.
All right.
But before I go into it, I want to paint this picture. I built a network for programs to communicate with each other, so you could think of me as building the roads. The programs would essentially be the cars. So I work more in a support role. So if the road is in there or the network is in there, then none of the programs should work. Well, we set up the buildings so they can work independently for about a day and a half. But if they don't talk back to the home base in enough time, then we can have issues. Or if there's a temperature change while they're disconnected, we can have issues. With that being said, every building has, say, a card that's a variable fan card. And what this card does is, depending on what the program tells it, it will change how much airflow it's allowing to happen inside a room. Now, it gets this information from another card that's further up in the building. So actually, the first card would be in the basement, and then this card would say be in the first floor or the second floor. In order for these two devices to communicate, we have network switches between them. So the scenario I'm getting to is if the network switch is broke, then this secondary card doesn't have a path to communicate to the primary card. And if, say, we had a room that was empty and now students come in, the humidity changes in there. You might have to turn up the fan so you can get the humidity out. Well, that doesn't happen, and we get a bunch of grumpy students that contact us. So I'm usually looking for issues like that are pretty obvious. When a device is broken, it's pretty clear that it's broken and we need to replace it. But sometimes we get other issues where we have some corrupt packets coming through. And it has a little bit to do with the programming, but there are some networking things we can do to limit the damage that a bad program's doing.
So, Larry, when something does actually go wrong, what indication do you get that it's wrong? What kind of monitoring systems are in place, and what do you interface with on a day-to-day basis to review the functionality of your network?
So there are two sides to monitor things, and the one side is the programming side, or just the room. So, for instance, we have certain temperatures in rooms for professors to do research. And say he needs the room to be 68 degrees so he can grow a certain type of product or something. If the room is 69 degrees or 67, that's our first interaction. So our customers can sometimes be our first line of defense, let us know that something's wrong. And the first step in this case would be to look at the program and see if that's broken. And if it's not a programming issue, then typically it's networking. So that's one way if we're not proactive about it and we don't catch it. And sometimes we get outages that we just can't be proactive about. On a proactive side, we do use a few network monitoring tools. I use one called OpenNMS. It's a free network monitoring tool. And what it does is I have it set up in a pretty basic mode, but it tells me when switches and routers go online and offline. Now, we're a 24/7, 365 shop, so none of our devices should be going online or offline ever. So that's very important for us to know that. So I'll get an email notification whenever those go offline. Another product that I use is another freeware called Observium. And what that allows me to do is I can look at the network links. So we have switches. And some of them have 12 ports, 24 ports, and 48 ports. And what I can do with Observium is look at how much throughput or pretty much how much data each port is transferring inside a building. And that is very important information. We have a few servers, and sometimes we'll have issues with the servers, and we need to find out if one server was transferring too much or not. And if we have thresholds that we set, so if we have a device that we know should only be transferring, say, over the course of an hour, maybe, let's just say 1 gig, keep numbers easy, and it's transferred 3 gigs over the course of an hour, that's 300% increase. That lets me know I should look into that. So we have a few tools like that, mainly for network monitoring, and then our programs, they run a protocol called Bacnet. It's created by AshRay. I don't remember when, but this protocol pretty much makes it so that all building automation devices are speaking the same language. Historically, when all these building automation devices were coming online, that's what every industry everyone, say you had a Johnson's product, then Johnson's stuff can only talk to Johnson. And if you had a Siemens product, then they can only talk their own stuff. Every company spoke their own proprietary language because they wanted to lock you into buying their product. But that's not necessarily good for the customer. You get locked into a product that you don't like. And the only way that you can improve your system is now to switch to a completely different company. So Bacnet was created to bypass that and to help customers integrate different products so they weren't stuck with one company. And with that being said, Bacnet is the protocol we use in our network. We have a tool called Bacnet LAN Monitor that specifically looks at traffic coming from Bacnet devices. So some buildings we know they should be, this kind of gets down to looking at the network switch throughput too, but we have some buildings that should be sending maybe, say, 2,000 packets per hour. That's it. So when we see a spike in that probably means either somebody added a new device without letting us know, or there's something wrong in the program. So we have 3 ways to check things. We check for up-down status with OpenNMS, up-down status of the actual device to switch. We look at throughput and Observium, and we usually use that for servers. And then we just look at the rate that the programs are communicating with each other using the Bacnet LAN Monitor.
Cool, man. So you used the analogy earlier that you kind of build a roadway or the roads for this information to kind of travel. So when you were designing this network, what were some of the things that you had to consider to make sure that it worked optimally and met the needs of your customers, as you call them, the professors and the various stakeholders there at the college or the university?
Okay, so the network, we're actually in the process of redesigning the network to make it more efficient. And as I said before, we're using the Bacnet protocol. It communicates a little bit differently than other IT protocols. So the way we built the new design was based off of that. There was a caveat that we have a current network up, and we can't have any downtime, as I said before. So one of the things we had to come up with was a design that says, let's make sure the network is always up. We have two. Well, we redesigned the core first because that's the most important part, and I ultimately said, let's take the current network and the new network that we're designing and kind of put it in place, like side by side with the old network, and then we'll switch devices one at a time. So whenever we go into a new building to throw in the newer network that we're building, we also we keep the old network up and the new network up so that we can transfer one device off at a time, and we test that so that way if that one device is broken, it's literally us unplugging it from the new switch and plugging it back into the old switch. But to get back more into the actual design, what we did before was we had a flat layer 2 network across 300 buildings, and that probably doesn't mean very much to you guys.
Yeah, that's what I was going to ask. What would the best analogy for a flat layer 2 network be?
So that would be so network switches. Let's think of them as I'll try to explain it in a normal way first, and then try to give an analogy.
Okay.
So what network switches do is if you plug your device into a port, one device and another device into a port, if they have devices usually have IP addresses. If their IP addresses are within a certain range, pretty much in the same group, they can communicate with each other without using a router. And that's for one-to-one traffic and for broadcast. So like when a device broadcasts, that means it's going to send a message to everything. It doesn't put a destination device. It just says, whoever can hear this, I'm going to send this message to and listen to it. So we have a network like that going through 300 buildings on campus. I guess the best analogy would be you have a bunch of people talking on the phone, on speakerphone, and they're all trying to talk at once. And you're trying to decipher what messages are for you as opposed to what messages are for somebody else. that's pretty much how our network was. It worked, but it wasn't really efficient. So what we did now, I'll put it this way. So now we have a building, Millennium Science Building, and if it had to send a broadcast that essentially had to be heard by my building, the Office of Physical Plant, Rec Hall building, for those that's a gym building on campus, would hear that broadcast, even though it doesn't need to talk to it. Trying to think of another building. A dining commons building would also hear that. So it's just very inefficient use of technology, and it can cause issues because if this building, Millennium Science Building, was actually sending out erroneous data and sending out way too many packets, that means it's broadcasting to every single building on campus, and one building essentially could take down everything else. So that sounds like a huge issue, and we've been affected by that quite a few times when technicians maybe installed something incorrectly or something like that, or the program wasn't working the way that they had it working in R&D. So with this new design, what we did is we isolated each building and we gave it its own broadcast domain. So that means when a building has a problem or it needs to send out a broadcast, it will be kept within the building. So there's no way one building can bring down a bunch of other buildings. If Millennium Science goes crazy, Millennium Science is the only building on campus that will be down. And from a design perspective, it's great. From a troubleshooting perspective, it saves so much time because with the current network, the older one, I mean, things are getting better now, but just trying to troubleshoot when every single building is off on campus and you're trying to figure out why that's happened, it's pretty hard to go back in time. I haven't figured out yet, but it's hard to go back in time to find out which building initiated this. So it creates quite a few headaches. And usually, with the old design, we had to wait for the broadcast storm to kind of die down and then see what buildings were still offline. That's how we troubleshooted before. It's pretty bad at the time. Yeah. But we're getting more efficient moving forward. Did I answer your question right? I don't know.
Oh yeah, no, that is it's there's so many different things involved, and we really just wanted to let you explain that. So let's take the time, maybe just go. I think you gave a great overview of network engineering from the technical aspect. Let's talk about you a little bit. How'd you first get interested in this field?
Well, to be honest, I graduated from Penn State as an electrical engineer, and I fell into this career from an internship. I knew nothing about IT, but personally, I like challenges and I like solving things. What I like the most, though, about network engineering is the designing aspect. And my favorite class in EE was circuit design. There are kind of some corollaries between the two. You have devices, and you need to put them together in a specific way and run a few commands to make them do exactly what you want. So I like that puzzle building aspect of it. But as I said before, I kind of fell into it. My previous supervisor gave me a few white papers to read on stuff, and then I found the Cisco certifications, and I took a few of those, and here I am.
And what I really love about that story, and what I like to highlight, is you moved forward in a STEM field, but you didn't end up where you might have expected it. It was the root is really that problem solving mindset, but you were able to get into something that had very little, or only kind of the base level of what you're doing now. That's a great story.
Yeah.
You mentioned the Cisco certifications, and I think in a conversation about network engineering, we'd be remiss if we just didn't if you could just give a quick explanation as to why that kind of certification is important and what it means to your job and your work.
There are quite a few IT certifications out there, and I know at the time when I took mine, Cisco was the one you should have. I think IT certifications are important, at least the first level, because they give you the knowledge on how to do certain things. And in networking. For instance, Cisco, their first certification taught me about IP subnets and just simple routing and switching and some basic security stuff. That stuff is the same across the board, no matter what vendor you work with. And the only thing that changes is you can think of the different vendors as being different dialects. So you're still speaking the same language, but they have a twist on how they do it. Cisco was the easiest. Lots of vendors actually base their command line based on Cisco. So if you can configure a Cisco switch, then more than likely you can configure almost any other switch or router that you're given. Another company that's out there that's good is Brocade. So they're saying they give you the knowledge, but it also shows your supervisor or your employer that you're willing to put in the time to learn what you need to do for your job. I could not have walked into my job with no knowledge of anything and done it. I could not have gone into these exams with no knowledge and passed these exams. So you definitely learn something. And the thing that's great about these exams is they test for application of the knowledge. I'm sure everyone's taken exams before where you just have to memorize a few facts and then you get it right. There are a few fact question and answers on these exams, but a lot of them are like mini labs where you have to, they say, this is what you have, this is what we want, figure it out. And that is probably the closest thing to work that you're going to get in an exam. So I think it helps train you for your job. And if you think you're interested in doing network design, go for one of these exams. And if you don't like what you're taking, then maybe you're not interested in network design. I'll let you know right away. But it's definitely a great thing to keep on your resume. I really think there's no way, even if you've been working in networking for years and you feel like you shouldn't get a certification, it helps get your foot in the door. It's just, I mean, that guy that's been doing this for like 20 or 30 years and doesn't have a certification, he might be wondering why he's not getting a promotion, as opposed to a guy that's been doing it for like 5 years and he got the certification. He did that extra work. You did it. You took some time out of your day to work at something and get better. And if you work for a good company, I think they'll respect that.
So you talked about kind of some advice really for people wanting to get interested in field. What other things do you see on the horizon, or that you might have an idea, completely separate of your Penn State work? What's something that you're potentially interested in?
Like
the future.
Non-work related?
Yeah.
Like karate stuff?
No, maybe not. Maybe something else to deal with science, technology, engineering, and that.
Okay. Right now I'm in grad school for enterprise architecture. That's it's a mixture of business and IT. This is like I'm only 9 credits in. I don't have my master's yet. So if there's an enterprise architect listening to this, don't get mad if I mess up the definition. But to me, so far, what enterprise architecture is taking the business and modeling it, taking the business model, but then adding structure to it also. So lots of businesses will have a model and say, "Hey, this is what we need. This is what we do. This, and that." But they might not have. They might not know the reasons why they're doing it. So you're trying to make that efficient. And now today, to create a business model and to leave out the IT aspect, the model's probably going to fail. Like, I'm pretty sure, I'm going to just say that about 90% of all business functions involve IT in some way, shape, or form. So it's bringing IT to the forefront, because IT has been seen more so as a support part of the business, but it's now pretty much a major line of business. So that's pretty much what it is. Saying, how can this business be more efficient? And at the same time, let's not forget about the IT aspects. So when we're thinking about increasing our revenue and decreasing costs, how does that affect what we're doing in IT? Like, do we need to make sure our databases from this part of the company is working with this part? And is our security okay? And how are we going to transfer information efficiently? Maybe the business might say, okay, this aspect of the business that we're doing IT in, we outsource it to someone else because they do it more efficiently than we do. But it's not just saying, okay, we need to make money, so let's sell some more T-shirts and give me money. That's one of the things I'm doing. And then I do read articles about some of the new technologies coming out. Something that I'm very interested in right now is what's called software-defined networking. And that's just a quick overview. What it's doing, as opposed to you having a separate switch and a router to do your networking stuff, is taking that stuff and condensing it down to like one box that can do switching and routing, and you're doing everything within software. So it's happening virtually. The programs are doing what the hardware was doing, and it limits the size of your data center.
Wow.
And it's just reduce cost. I mean, thinking of it from, the box that you're buying is probably going to be pretty expensive to do that, but you're saving costs on wiring. You have less appliances that you need to have running now, so you save energy costs in the long run too. So it's very beneficial to companies to be looking at solutions like these.
How do you see something like that affecting sort of like these big, huge data centers that are, they seem pretty prevalent nowadays?
As I was saying before, like it reduces, I guess, the physical space. So I think data centers are going to be, I think they'll probably be the same size, but they'll be able to fit more in there. So let's just say, just talk about like one rack. In my department, we have 2 or 3 servers, physical servers that are running something called VMware. This pretty much takes a virtualized server. So what that means is you're running multiple computers on one physical hardware appliance. So we have 2 of those in a rack, and then we have 2 or 3 switches to make the interconnections between the 2 separate servers, and then we may have a router in there. So with this software-defined networking, so I said 2 servers, 2 switches, and a router. So that's 5 devices inside that rack, 5 power supplies, actually, or 10 power supplies because we're going dual power everything.
Wow.
And let's just say we have, 10 cables total between everything. Now, with the software-defined networking, we probably buy, and I just started the researching, we would probably be able to buy one server and run a virtual software on that server and have all the virtual machines and the networking equipment be on one physical device. And we would just only have to provide a power supply to that one server. So in that server, we have software that's running all the virtual servers we were running before, and then software for those physical switches that we had, the 2 switches, and the 1 router. That would all be software. And there would be like 1 or 2 network cables going to a physical switch. Mm-hmm. So we reduced our switch down to 1 switch, and we took our power supplies down. We probably have now 4, so we went from 10 to 4 power supplies. So we reduced the size of our physical footprint, and if you are environmentally conscious, our carbon footprint too. Reduce both of those, but we still have the same functionality. So now take that with a company that specializes in selling you server space and stuff like that. They can offer so many more products with less equipment or less overhead, if you think that way. So I don't think the data centers are going to get smaller, but I think they're going to be able to offer a lot more to customers with the same amount of equipment. The same or less equipment, I'll put it that way.
All right. Man. So the network engineer of the future, he or she would be looking at doing a lot of the work that maybe is done today physically by checking certain pieces of hardware, multiple pieces of hardware. It's now going to be condensed into one area, and now they're basically just looking at the functionality on some type of read whatever the software would read out to a screen or something like that.
Yep, pretty much. They would just program it all in the software.
Okay.
So looking into the future and really how we want to really look to wrap up the conversation, imagine talking to somebody. We hope the listeners of our podcast are either individuals who are starting to get interested in science, technology, engineering, math, anyone who's interested in getting into the various fields of the people that we interview, or even if someone has no idea what to do, and they're seeking some information or some knowledge. What advice would you give somebody?
If they're seeking knowledge in general about STEM or networking?
Probably the network engineering piece. So you mentioned that you were given white papers to read. You just talked about how you're in graduate school pursuing additional knowledge on a formal basis, and then you just mentioned that you're reading about this whole new software enabled network type of situation. So what are some of the sources that someone, let's say from like high school freshman through a freshman in college, if they're interested in network engineering and want to learn more about it, what are some of the sources they could go to?
I use a lot of forums, and luckily in high school, or ironically in high school, I was in a Cisco networking course, but I said I'm never going to use this. So I don't know how much you should listen to me on this, but I would, if they have an interest and if they have access to the internet, I would just literally do a Google search on networking. There's a website that I go to, and this is mainly just to learn programming. It's a site called Stack Overflow, and they offer courses for like $10 or $15. You can get like a 10-lesson course to learn how to do Java or something like that. And I think they have a few networking courses too. But another thing, and this is very dependent on if they have access to the internet. I don't know if you guys ever talked about Moocs yet, the free online learning. So there's sites like Coursera or CourseRA.com. I take classes on that every once in a while. If you want to get a certificate, you have to pay for it. I'm paying for grad school, so I don't get the certificate for these courses. But you can enroll in these courses, and they have a lot of free network design and introduction courses and just stuff on computers in general and IT. So that's probably what I would recommend if they want the formal learning. But if they're more informal, I'd search Google and find a forum and become active in a forum and see what they can learn. I do know Brocade, that's Brocade. They offer a lot of free stuff on their website. I think you can take you can take some entry level IT classes with them and get a certificate from those guys. And then when you want to move on to the higher levels of doing some routing and stuff like that on our switches, then you have to pay for those courses. But you can still get a pretty solid basis for free from them. So Brocade's a good source to go to. The Coursera and see what they have. A bunch of colleges. Penn State offers some courses. MIT offers a really good cryptology course and stuff about making sure your data is encrypted. Cryptology. University of Penn has a few good courses. I think Stanford University has another course on encryption also. So yeah, there are a lot of colleges on Coursera too. So I check all those sources that I mentioned.
How did you like the Mooc that you do? Do you know which one you took? There are a couple different ones out there.
I went to Coursera and I took one on I'm trying to remember the name now, but it was about the social aspects of IT, and it was a little bit more, not super technical. It was just talking about how social media is interacting with our lives and stuff like that. And that wasn't too bad. It was pretty interesting. I took the Stanford cryptology course, and I will say, if you are a high school student and you've taken calculus, then I recommend that course. It's very heavy on calculus, and there's a lot of statistics. So just be comfortable with the calculus. The course moves pretty fast.
Which course is that again?
Oh, it's the encryption course.
Encryption.
Stanford University, or I think cryptology. I can't remember the name, but there's a lot of probability that goes on to encrypting packets to make sure someone else can't decipher it. So those were the two I took. There were a few I looked at, but I just haven't had the time to complete them.
Yeah, maybe have to bring you back for a conversation on cryptology or something.
Gotta look at my notes, man.
Yeah. Awesome. Any other major issues that we wanted to touch base while we have Larry Bassir?
Oh, I think there's so many. We're starting to hit a little bit towards the end of our time.
Okay. Very good. Well, Larry, thank you so much for joining us this episode, and I'm sure there are a ton of other things that are involved with network engineering, and just it sounds like you're learning more and more about various areas of IT. So as we continue on and do more and more shows, and some of the things, if you want to share some of the knowledge that you acquire through your classes and different things like that, we would love to bring you on to do some of that and talk about some other topics. But this was a great overview of the network engineering field and kind of the work that you're doing.
Yeah, thanks for having me, guys. And when you guys get some free time, I'm always open to teaching and just spreading some knowledge and, I guess, the joy of what I do to help more people get into the STEM field.
Yeah,
I think it's always worth it.
Absolutely.
Very good deal. Thanks again, Larry. We'll talk to you soon. And welcome back. We want to thank Larry Murray for a great conversation. Bassir, how great was Larry?
Ah, he's the best.
Yeah.
That's my best friend. So,
and I mean, he's just very knowledgeable as well, and that hopefully came through to the listeners. I know it was very apparent to me when I was talking to him just how much knowledge and information he has about IT networks. And
that's the importance. He can translate. He can control what these pieces are.
Absolutely. Okay, well, there was a lot of great information, as we said, that Larry provided. So before we close out today's show, we wanted to give you 3 takeaways, 3 key points, 3 key areas that we feel are the most relevant topics, relevant pieces of information that came out of the discussion and come out of today's episode as a whole. And so we hope you're able to follow up with these takeaways. And if you have further questions about them or want to get more information on these takeaways or how you can learn more about them, you can contact us at our email address, stembros@gmail.com. That's stembros@gmail.com. So, first takeaway from today's episode is recognizing that today's modern buildings and the buildings of the future will all be controlled by equipment and devices that are connected to IT networks so that they can be controlled automatically and remotely. Very important. Today's modern buildings are all going to have some type of advanced network that connects the various systems in that building, the heating, ventilation, air conditioning, all that kind of thing, as well as the lights, as we talked about at the beginning of the podcast, locks and doors, and other items that help buildings run.
And that's just the tip of the iceberg. Larry mentioned a little bit about what he does with, he'll know whether an AC unit's out. But in the future, everyone's going to want to take advantage of money-saving opportunities and being able to control your HVAC to keep a certain building a certain temperature only when it's occupied or not occupied. That's a huge money-saving venture. That's how companies will learn to be as eco-friendly as possible going into the future.
Definitely. Second takeaway. Network engineers. When you see that job title, careers and when you're thinking about careers in network network engineering, just remember network engineers are going to be needed more than ever. They're needed in abundance today, and they're going to be needed more than ever in the future, because network engineers are needed to set up and maintain the IT networks that all these different pieces of equipment, all these buildings, these smart buildings will be using to operate. So the network engineers set up, they build, as Larry used the analogy of the roadway, they set up, they build these roads. And just remember the difference between a network engineer and then the roadway analogy as somebody building actual physical roads is that the network engineers, their roadways consist of hardware and software that are connected and they communicate with one another.
And you said it best. There's going to be jobs, and there's going to be jobs in different levels. So maybe not exactly what Larry is doing, but maybe one of the cars that's on the roadways or some other aspect of it. This podcast is to give examples of the various jobs that make up this entire system. And that's what I hope everyone listening to this takes away. It's a potential opportunity, which is a potential job that you or your son or your daughter or anyone listening to this could potentially have going into the future.
Very well said. And the third and final takeaway from today's episode, and perhaps the most important, is the fact that technology changes fast. So there's a lot to learn, and we have to be continuous learners. The days of going to school and sort of saying, oh, that's it, I'm done, I'm never going to learn anything new again, and I'm just going to be able to get through life accordingly. That day's over. Technology is changing too fast. We have to constantly be learning. But that doesn't mean you have to go and pay $30,000 a year tuition at some school, right? Like Larry pointed out towards the end, there are a lot of free or very low-cost resources out there to educate yourself on the different areas of technology. Larry mentioned Moocs, but I don't believe he stated what Mooc stands for. It's MOOC. That's an acronym that stands for Massive Open Online Course. And these are prevalent. There are a couple big providers out there, but there are a lot of colleges and universities, including some of the best in the world, like Harvard and Stanford, that run Moocs, these massive open online courses, and you can take them for little or no money. Right. And this gives you an opportunity to learn and brush up on new technology skills, or at least make yourself aware, even if you're not going to go out there and program in some new advanced language, at least being aware that the language exists and what it consists of, and understanding what's changing and the technology behind the things that we interact with on a day-to-day basis. It's very important to learn these things, and Moocs are a great way to do that. So they're a great way to enhance one's career. They're a great way to just educate yourself about the world around you. And again, Mooc, massive open online courses, that's just one way. There are other resources out there where you can learn more and more about technology, science, engineering, math, and just about anything that will help you interact with the world in our ever-changing, technologically advanced world.
And that is the essence of this podcast. If the listeners listen to episode 1, we talked about the idea of all the things around us. There's so many items that people look at and don't know how to explain or understand, and it almost seems like magic. And what we're trying to give is essentially the spell books. We want people to know where you can go to understand what's behind being able to unlock your door from a cell phone. And that's the importance of knowing and learning and getting into science, technology, engineering, and math. It's how you find out about the things that are going to be shaping our future.
Again, excellent synopsis, Baser, and excellent points. Just to finish out with that third and final area, that third and final takeaway, if you want to learn more about Moocs, I would suggest checking out edx.org or Coursera, Coursera.org. Those are two of the major platforms for the massive online course ecosystem. So you can find a lot of courses there, and they will take you, give you a menu, give you some options. You can learn more about how these courses work and everything from either of those two sites. So that's a great place to start. So that brings us to the end of episode 6 of the STEM Brothers podcast. I want to thank everyone for joining us. Thank you for listening. Baser, thank you. Any closing words?
No, definitely like to thank Larry Murray for giving his time, and look forward to our next episode.
Looking forward to it as well. And remember, if you want to contact us, questions, suggestions, please shoot us an email at stembros@gmail.com. That's stembros@gmail.com. Thank you, everybody. We look forward to seeing you on the next episode of The STEM Brothers. We are gone.